1. So we can actually say 3-methyl but 1 in. Is that not so? But I said sometimes, because it is on carbon number 1, they do write 3-methyl butene. But in this case, they said you should identify the position of your what? Of your double bond. That's why it is what? But 1 what? But 1 in. Are we together? Are we on the same page? So that's why we have but 1 in. Sister Idaya.
Sir.
Are we
Okay.
together?
Yes, sir. Thank you so much. I understand. The reason why I picked the second one was I made a mistake. I started counting from the
From
front.
from the left side. From
Yes,
the
from
left
the
side,
left.
right? Yeah, you cannot
Yes.
start something. So we need to follow the rules. Is that okay?
Yes, sir.
So because I don't think you are you in were you in the class in on last week Monday?
No, sir.
So that's why. So we've said a lot about this. So you can easily go and watch the video.
Okay, sir.
So
Sir,
okay.
please, just one quick question. It's not going to take your time, sir.
Okay, no problem.
Sorry. Yes. So the question is on the acid base and salts that I've done before.
Okay.
Yes. So the question is the compound that makes palm wine taste sour after exposure to air for a few days is A. Ethanol, B. Ethanoic acid, and C. Methanol. So when I picked an ethanoic acid, it was wrong. So this is ethanol, and they are both compounds. So I was confused, like what to pick if you see ethanol and ethanoic acid. Thank you, sir.
Okay, is it the structure or the answer to to that
No,
particular question?
the answer to that particular question. That the
Let's write
compound that makes
let's write the question down so that people will benefit from it. Is that okay?
yes, sir.
Okay. Go on with that question back.
The compound.
Wait, I'm coming.
Okay.
Okay, the compound
That
mhm,
makes
that makes
palm wine
palm wine
taste
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 sour,
what?
sour, sour.
Okay,
Yes,
okay.
after exposure
After exposure
to the air.
to the air
For a few days.
for a few days, we shall know that after exposure to the air for few days.
Yeah,
Number
is
one, number one, you said it's
ethanol.
ethanoic acid, right?
Yes, sir.
Number two, B is ethanol.
Ethanol.
Uh-huh.
Then C is methanol. That one is out of the um,
Methanol. This one is out of the option, right?
yes, it's out of the option.
Okay, let me just, okay, before I can explain this, class, are we together? Yes. The first thing is that I'm going to start from this, methanol. So I'm going to start from methanol. When we said methanol, is from alkanol, right? Is that not so? Now, that's the first family of alkanol. So this methanol itself, we said methanol is formed. This methanol, you can put it down. Methanol is formed from destructive distillation of wood. What do I call it? Destructive distillation of what? Of wood. That's how this methanol is formed. Methanol is formed from destructive distillation of wood. And this methanol, when people digest it, it causes eye blindness. Are we together? What do I said it causes? It causes what? Eye
Eye
blindness.
blindness.
Yes. And this
Blindness.
methanol itself, yes, this methanol itself, they use it. Why do people cannot digest it? Is that because it is formed from what? Destructive distillation of what? Of wood. So we all know what we call the methylated spirit. Are we together? Methylated spirit. So
Okay.
this methanol, it is used for what? For methylated spirits. That's why you could find that people cannot even drink methylated spirits. Anybody who try it, we have a problem with his or her eye. That's why they said this methanol is something that causes problem to people when digested it. You know, people can taste ethanol. Is that also? So it is something that people do take. So we found ethanol, yeah, exactly. So, but this methanol, because it is the first member and it is gotten from destructive distillation of wood, the wood that are the what that have been destructive. So, so that's why they said it causes what? Eye blindness. And people cannot digest methylated spirit. Fine. They use it. What do they use methylated spirit to do? You can tell me.
On
What do they
injury.
use for injury? So they use it for injury. So that's why you could find it in an hospital. Can someone now digest such things? No. So that's why they said, okay, you don't understand. I mean, Amida, are you with
No,
us?
sir. No, yes, sir.
Okay, what does that mean? What's your tongue?
When you
What does it
said
mean?
someone cannot digest methylated spirits, so I
Yeah, it was like, okay, have you seen anybody that have digested it before?
no, sir. That's what I'm trying to say. That it's not
Okay,
possible.
okay, it is not possible. Okay, exactly. So because it will use what? It will cause eye blindness. So that's why it is out of it. But what they actually say here is that the compound that makes palm wine taste sour. Palm wine. What is palm wine? Is it ethanoic acid? What do we call palm wine? What do we call palm wine in Yoruba?
Emu.
Emo,
Yeah, we call it emo, right? So
oguro.
oguro, exactly. So what do we uh, okay, when someone consume this palm wine, more of it, what does it cause to the body?
It intoxicates the person.
Toxic effect, exactly. It causes problem that's why you see some babas who are old and consume this palm wine, they will be doing something like they will be doing something else. It's senseless. Is that also? So that's why we said it is what? It is part of this palm wine itself is part of what? Alcanol. It's part of what? Alcanol. It is alcohol. They call it alcohol. Is that also? But now,
Yes.
this this ethanoic acid. So it is something, ethanoic acid is something that is formed from something. We get it from something else. That's why they said ethanoic acid. Where can you find ethanoic acid? You found it in vinegar. You found it in what? In vinegar. So all these acid, the mineral acid that we said, we found it from natural substances. Are we together? It is not something that we put inside any other thing else. When we consume something, so that's when we said, the acid that is being gotten from this particular natural substances is what? Is ethanoic acid. I absorb lactic acid from these substances. I absorb something like this from these substances. Are we together? That's why they said, okay, what kind of acid do you get from what's your this thing, your orange that you drink? They said it is citrus. We found what? Citric acid. Is that also? So we get all this acid from our substances. That's why we call it what? Mineral acid. Are we together? We get it from something that comes from nature. So unlike this ethanol, you know that when ethanol is something that can be mixed with any other thing else. I don't think you get what I'm saying. Are we together? So now this ethanol, we all know where this ethanol can be found. So we also call it alcohol. Do you understand? This compound is the one when palm wine itself is alcohol, is what? Alcanol. Palm wine itself is alcanol. But what make it taste sour? What make it taste sour? If you go to an acid, how does an acid taste? Acid itself. What's
So
the taste of an acid? Sour. Fine. That's good. But the question that they asked here is that the compound that makes palm wine taste sour after exposure to the air for a few days. Palm wine is something alcanol. Is that not so? Now, what they're actually saying is that in that palm wine is alcanol, and we have ethanol also is part of palm wine. What is inside that palm wine that makes it taste sour after being exposed to the what? To the air? Emu, oguro, that they usually drink. Can someone tell me that do they expose it to air? No, they usually covered it because when they expose it to air, it will start tasting sour. Are we together? So what is inside that palm wine that makes it taste sour when exposed to the atmosphere? It is what? Something ethanol, not ethanoic acid. Are we together? Exactly. So that's the correct answer. Have I answered your question?
yes, sir. Thank you, sir.
That's fine. So I think we gain a lot of things here, right? Okay, any other question we have from our brothers and sisters before we proceed? Amidat, any question? Do you have
No,
any
sir.
question? Okay, no question. Okay. So now, today we want to talk about the types of reaction that we have in chemistry. Types of reaction that we have. So I want us to be fast with it. So as something we've known already. So in chemistry, when we say the reaction, so that means that it must entails two things, right? So who can tell me the two things that we must have in reaction? In reaction, I said we must have the two things. So when talking when talking about reaction, we must have two things. Number one, we must have what we call the reactant, right? And what's number two? We must have what? We must have what we call the what? A product. That shows that,
Product.
yes, that shows that without reactants, we cannot have what? We cannot have our product, right? So in this case, we should, in chemistry, we should be able to know when we have a reaction, when we have different reaction, we should know that, oh, what kind of reaction is this? Is it decomposition reaction? Is it normal reaction? Is it combination reaction, decomposition, displacement reaction? Is this catalytic reaction? And so on and so forth. So that's what we need to know. So, and we said we must have a reactant before we have what? Before we have the product. So that's why we have what we call the mole ratio. What do I call it? Mole ratio. What do we mean by mole ratio? Mole ratio is when reactants combine, when your reactant combine and your product is formed. Reactant combine and what? And the product is what? Is formed. So that's what we have as reactant. Are we together? Hello, are we together? So that's what we called reactant. Please excuse me for 1 minute. I'm still with you. I'm with you. Not that I went off. I'm still with you. Okay, fine. Are we together? Hello. So now, so when we talk about the types of reaction, so as I said earlier, I said for a reaction, for we to have a reaction, we must have things, which is what? They are what? They are the reactant and what? And the product. And I told you that we have what we call the mole ratio, right? I said mole ratio is when reactants combine and product is what? Is formed. So let me just quickly list the types of reaction that we have in chemistry. So number one, we have combination reaction, combination reaction. So number two, we have what we call decomposition reaction, decomposition reaction. Number three, we have what we call displacement reaction, displacement reaction. Number four, we have what we call double decomposition, decomposition. Number five, we have what we call catalytic reaction. Catalytic reaction is something you should be familiar with. Catalytic reaction. So, yes. Now, but the next one, we have what we call reversible reaction. Reversible. So, reversible reaction, we have thermal dissociation. We have thermal dissociation. Who can give me the next one that we have? We have oxidation and reduction reaction. These are the types of reaction that we have. So oxidation and reduction reaction. So let's start with the first one, which is the combination reaction. When we said combination, the word combination, it means combine. It means that when two or more substances combine, two or more substances. So that is, we can have two substances combined together, or we have more substances combined together to form a compound. To form a what? A compound. So that's what we called what? That's what we called combination reaction. Let me just give you an example. So in combination reaction, when we said combination, I said, what do I call combination reaction for you? What do I call combination reaction? I said combination reaction is when what?
Is when two or more substances combine together to form a compound.
To form a compound. That shows that it is what? Elements plus elements. When two elements or more elements react together to form what? To form a what? A compound. To form a what? A compound. That shows that one element can combine with other element, or more elements can combine together to form a what? To form a compound. Example, when you have iron, the state of iron is solid, plus when we have sulfur, when they combine together, they give what? It will give what? Who can tell us? They want to form a compound. It will give us iron what?
Iron sulfide.
Iron
Iron
sulfide.
sulfide. So that's what we called what? Combination reaction. So two or more compounds together to form a what? To form two or more elements combined together to form what? To form a compound. Another example I can give you, yes, compound can also, there's difference between element and compound. So from the definition of combination reaction, I said combination reaction is when two or more substances. It does not limit itself to element only, but we can also have two or more compounds combined together to form a bigger compound. Is that also? So it's still combination. They combine together. Example is lead oxide. When we have PbO, lead oxide. So is this correct? So we have PbO2 when solid, when it reacts with what? With SO2, sulfur oxide. So sulfur oxide, which is in gaseous state, to gives PbSO4. PbSO4. So are we together? So this is two or more compounds. So two compound combined together to form a what? A bigger compound. That's what we call combination reaction. You can actually put it down. So let's go to decomposition reaction. So when we say combination, it is something combined together. Decomposition, it is opposite of combination. Are we together? So decomposition, it means that when a single compound is split into two or more simpler substances, you will see that it is actually the opposite of what? Of combination reaction. Are we together? So decomposition is when what? A single compound, we have a single compound which is split into what? Splitting up into two or more substances. Are we together? So example that I can give you is that when we have lead triazonitrate, so when we have PbNO3, this is NO3. So have you written this? Okay, fine. That's fine. So when we have PbNO3 too, so it is splitted. Now, something in the composition, something in the reaction is that, when we are dealing with acid, base, and salt, during the time we are doing acid, base, and salt, we said when acid reacts with triazocarbonate, what we said it happens? Who can still remind us? When acid reacts with triazocarbonate, maybe H2SO4, when it reacts with triazocarbonate, CaCO3, what will happen, please? What will it vibrate? Who still remember this?
CO2,
We are going to have
CO2
CO2
salt and
gas
water.
and water, right? And with what? With salt. Is that also? What salt are we going to have here? What salt? That's CaSO4. Are we together? CaSO4. So now, likewise, this one as well. During the composition reaction, this NO3 will split into NO2. It will split into what? NO2. We are going to have NO2 gas, which is what? With oxygen gas. Are we together? So the next one we are going to have is PbO. PbO. So now, it means that why we said it is the composition reaction is that this is a single compound. This is a single compound splitting up into two or more what? Two or more simpler substances. Are we together? So how do we get PbNO32? You know, Pb is Pb2 plus in the electropositivity, while NO is NO3 minus. Is that also? Pb2
Yes,
plus
sir.
and NO3 minus. So the ion for this one is 2, while that of this one is what? 1. Is that also? What do we do to make it a compound? To make it a compound, what are we going to do in this aspect? We've done it all. What are we going to do?
We cross it.
We cross-link. So when we cross-link, that shows that this Pb will multiply 1. That's Pb. And
PB.
NO3, yeah, NO3 times 2 will now be NO3. You know, we have 2. So this is the 2. That's how we get this compound. Is that okay?
Yes.
It's not something that we are just doing it. So we have how we get this compound. Are we together? So now, in this case, this is PbNO32, which is splitting into what? Lead oxide with what? NO2 with what? With oxygen gas. Are we together? Are we together? So,
Yes,
Yes.
sir.
fine. So, what is the name of NO2? NO2 is what? NO2 is what? Okay, what of CO2? What do you call CO2?
Nitrogen oxide.
Carbon
What of
oxide.
what of NO?
Nitrogen oxide.
What is
Oxide.
NO2? Okay, what is CO?
Carbon 2 oxide.
CO.
Carbon oxide.
Carbon
Carbon
dioxide.
oxide.
Someone said carbon 2 oxide is CO.
No.
What of CO2?
Sulfur oxide.
Carbon 4
CO2.
oxide.
Yes.
Carbon 4 oxide, right?
Yes.
What of CO? Someone said carbon 2 oxide. Is that not so?
Yes.
That shows that you cannot talk now. You know something and you cannot talk. This is carbon 4 oxide. All right?
Yes.
This is carbon 2 oxide. I will tell you the differences now.
The oxidation number.
The oxidation number, thank you. The oxidation number of oxygen is what? What's the oxidation numbers of oxygen?
CO2.
Minus 2.
Plus
Minus 2. That's carbon
Minus 2.
plus
minus 2.
O2 equals 0. Minus 2, Abi. So it
Yes.
means that C plus minus 2 times 2, it is minus 4, right?
Minus
Equals to
4.
0.
Yes.
Plus times minus, right? Your C equals to
Yes.
what?
It's not
4.
4.
That's why you have carbon 4 oxide.
Oxide.
Are we together? This one
Yes.
will be carbon 2 oxide because CO we have C plus oxygen only, which is equals to 0. Oxygen is -2. That's C minus 2 equals to 0. Your C equals to 2. That's why we have carbon 2 oxide. This, after we call it carbon 4 oxide, because we name it based on the numbers of carbon. Carbon 4 oxide, carbon 2 oxide. But some you are going to be seeing CO2 as carbon dioxide. Is that not so?
Yes.
So carbon dioxide, because this oxygen here is 2, that's why they call it di. Carbon dioxide, that is oxide with 2. That's why they call it carbon dioxide. Why they call, because this one is 1, they call it carbon monoxide. I don't think you get it right.
Yes.
Yes.
I should recap, or what do you said?
We get it.
You get it right. Everybody gets it right, right? So,
Yes, yes.
so that's why we call it carbon monoxide, because of one oxygen. Monoxide, that is one oxygen. Carbon dioxide, because of 2 oxygen. So they still, yes, they still call it carbon 4 oxide because of that of the carbon that has the oxidation numbers of what? Of 4. I don't think, do we all get it right?
Yes, sir.
Exactly. So in this case, this one is nitrogen what? Nitrogen 4 oxide.
Oxide.
Are we together? Nitrogen 4 oxide. Why this one is what? Oxygen. Why this one is lead oxide. So you need to know their names. Okay. How do we get this? Who can tell me how we get PBO? PBO. How do we get PBO? Is this correct compound? Is it a correct compound? How do we get it? You should know that the oxygen number,
PBO.
we have Pb2 plus, thank you, Pb2 plus,
And the oxygen to
Two
minus.
that's O2 minus, that's fine, because they have the same thing. So nothing should be added. If you cross-link them, 2 will multiply oxygen and 2 will multiply this, that's Pb2, O2, right? So far they have the same number. This will cancel this, which remains what? PbO only. So that's why we have lead oxide. Are we together? I think we are getting it right. So
Yes.
this is how this compound is split. So this is what we call the decomposition reaction. Decomposition reaction is when a single compound is splitted into what? Into 2 or more substances. Are we together? Yeah, let's put it down. So the next one is that let's go to displacement reaction. So when we said displacement, I'll just give you one example so that you don't need to memorize everything offhand. So I'll just give you an example. Displace. That shows that we have, so it means that when you have a reactant, so, and one element in that reactant replace another element at the product side. You get it now. So, you know, from the properties of an acid, we said acid react with metals to liberate what? When acid reacts with metals, what does it liberate? When we have H2SO4, when it reacts with zinc solid, what are we going to get? It will liberate what? They said it's going to give us hydrogen gas. Is that not so? That shows that you are not following. No. It will liberate hydrogen gas. What will it remain? It remains Zn and SO4. So it will not be ZnSO4. So it means that this zinc displaces hydrogen. It displaces what? Hydrogen. Displace means that, yes, it removes hydrogen from what? From SO4. Are we together? That's what we call displacement reaction. So I will just give you an example. When you have A plus BY, don't forget that B is the owner of the Y. Are we together? But in this case, B has higher electropositivity than B. That shows that it's going to collect Y from what? From B, which will now be what? AY plus what? Plus B. I don't think we get it right.
You get it.
Yes. Why do we? I've said it more than one time that why do zinc displace hydrogen from SO4? Because in the electropositivity, zinc is higher than that of the what? Than the hydrogen. Are we together?
Hydro.
Likewise,
Yes.
that's why we call it what? Displacement reaction. You can put it down. So that's what we call displacement reaction. So what's the next one, please? What's the next type of reaction that we have?
Double decomposition.
Double decomposition.
Double decomposition. So let me just give you one example about double decomposition. So double decomposition, in double decomposition, what happens is that the reactants decompose reactants. We know decomposition now. You understand decomposition. Something is splitting, right? But in double decomposition, it means that the reactant decomposes to form new substance. It's what? The reactant decompose. That is, we are going to have not only one reactant, we are going to have two compounds at that reactant. That is, in double decomposition, the reactant decompose to form new substances by exchanging radicals. By what? Exchanging radicals. Exchanging what? Radicals. So I will just give you an example. So it's just the example that when we have AB plus CD, when we have AB plus CD, are we together? So A and C, they are the original value that we have there. This D and B is an attachment. So what will happen is that they will now exchange their radicals. This is the radicals, B and B. So definitely for A will take D, while C will take what?
D.
D.
B.
Are we together?
Now.
A will take D, while C will take what? We take B. Are we together? In that sense. So it's now be what? We are going to have AD, right? Plus what? Plus CB. Are we together? So what happens here is that they exchange their radicals. So that's what we call double decomposition. You know, in this case, we have two different compounds. Is that also? So I think, what time are you, when are you going for solar? When are you going for prayer?
420. 420.
420. Okay, fine.
415.
Someone said 4:15. Did we come back
Yes.
after our prayer, after our solar?
Yes, sir.
Okay, that's fine. Okay. We are going to stop by 4:15 and we come back.
But
Is that okay?
when are we coming back? By what time?
What time do you think we should come back?
445.
4:45, right?
Yeah.
That's fine. No problem. 4:45 stamped. Okay. Yeah, let's continue with this. So when we said we have double decomposition, it's actually, we get it right, Abby. So there is exchange of radicals. It's just exchange of what? Radicals. This exchange of radicals depends on high electronegativity and high electropositivity. I'll give you an example. When we have an example, we have AgNO3. We have AgNO3 when react with sodium chloride. Sodium chloride. Now, are we together, class? Okay. The metals, the electropositivity that we have here. What are the electropositivity that we have here?
Ag.
Ag
Sodium.
Na.
and sodium, Na. Which one is highly electropositivity between sodium and Ag?
Sodium.
Sodium. Are we together? That shows that electropositivity that we have here is Ag and Na. So these are radicals, NO3 and Cl. They are what? Radicals. Are we together?
Yes.
Are we together? Now, what will who can tell me what will happen here in this case with the example that we did up here? Who should tell me what are we going to have? You know, we have AB plus CD. So now, in this case, A takes the radicals from C, which is D, and C took the radicals of what? Of B. Are we not? Are we together? Okay, who can now tell me what will be our reactant? What will be our product now? Let's talk now. Definitely sodium we take NO3 from Ag.
Yes.
And we are going to have what? Na,
NaNO3
NO3
plus
plus
AgCl.
Cl. That's just simple thing. You need to understand. That's fine. So this is what we are going to have at the product side. It's just the exchange of radicals. So sodium is taking NO3 due to the fact that it is highly electropositivity than what? Than silver. Are we together?
Yes, sir.
I think that's okay for us, right?
Sir.
So let me just give you
Sir.
one example more, and
Sir,
you write it.
question.
That was your question. Yeah.
Can AgCl come first before NO3?
Ag,
Cl. Can AgCl come first before NaNO3?
it can come. It depends. You can write it anyway. This one is just precipitation reaction. Precipitation. So you will do it in your what's it in your practical. So quantitative analysis. So AgCl can come. It can come. It depends on the how you put it. You can put AgCl first. You can put NaNO3 first. Anyhow, are we together?
Yes, sir.
So if you want to follow this thing, AB plus CD, you know, in this case, the position of A is Ag, right? Position of B is NO3, right?
Yes.
And AD come first. AD come first. That's that A is our Ag. It can be Ag. What's our D in this case? Our D here is
Cl.
Cl plus what? NaNO3. Anyhow,
Yes.
are we together?
Yes, sir.
Let me just give you one example before we go for prayer. So, when you have something like this, NaCl plus H2SO4, what are we going to get here? That's where the problem will be.
Na
NaSO4 plus HCl.
NaSO4 and
NaSO4 plus
NaSO4 plus
Yes.
Oh yeah, what are we going to get?
NaSO4
NaSO4
plus
We are going to
HCl.
get
Plus HCl.
NaSO4 plus what?
Plus HCl.
HCl. Is this reaction complete?
No.
and we will add 2. So that is it.
We add 2.
Our hydrogen is 2.
We add 2. Chlorine has become 2 now.
Yes.
We add 2 to that.
2
We add
important
that
sodium
sodium.
chloride.
Sodium chloride and 2 to that NaSO4.
NaSO4, yes.
2 to that. Is it complete now?
That is
So
not
far as
clear.
become
It's
2
not
now.
clear.
It's not clear.
Yes.
No, you are the one telling me the answer now. Am I the one telling you the answer?
No.
So, okay, you said you are going to get this. Is that not so? That's what you said now.
Yes.
Yes.
You said NaCl and H2SO4, that we have NaSO4
Plus HCl.
and HCl. Is that also? That's what you told me.
Yes, sir.
Yes.
Yes, you now said we are going so far that we have 2 hydrogen here. Now we are going to have something like this here. That's what you told me. But actually, you should know this. You should know this because I told you the reaction between acid and salt. When acid reacts with salt, go and check your go and check go and check your book. When acid reacts with salt, what are we going to get? When acid reacts with salt, so when acid reacts with salt, we are still going to get acid with salt as well. But what kind of salt? So far that this acid that we have here, the acid that we have here is hydrogen. And
Egoni, big mommy.
so when we have something like this, when acid reacts with salt, that's why you need to be you need to understand what we've done so far. So when acid reacts with salt, and what kind of acid? Acid with what? With hydrogen. We are going to, is going to give us acid plus acidic salt. Acid plus what? Acidic salt. And how do we identify acidic salt? You know, we are going to have HCl, right? Is that not so? H with Cl here, but it remains one hydrogen. It remains what? One hydrogen.
Nitrogen.
Yes. Don't forget that Na is Na plus, and SO4 is SO4 2 minus. Is that not
Minus.
so? That shows
Plus.
that before these can be the same, that shows that sodium should be 2. So that's why hydrogen comes in, and we now have NaHSO4. This is acidic salt. This is what? Acidic
Acidic
salt.
salt.
Yes, so we've done it in our previous in our acid base and salt. The last reaction that we did, that when acid reacts with salt, we are going to get this kind of what? This kind of reaction. Are we together? So this is also double
Yes, sir.
decomposition. So let's go for solar and let's come back. Thank you very much.
Jazakumullah
So
khairan.
Thank you.
Jazakallah khair.
Jazakumullah khairan.
Ọmọ àdúrà yìí ti ṣe. Zobo. Abẹ́ padà ṣe. Ẹ padà ṣe. Zobo. Ń ga ká lọ kírun ká padà wá. Yeah. Mo ti gbàgbé. Ta ló fẹ́ bá wa? Orí chájà mi kọ́. Má. Orí chájà mi. Ìwọ ló máa ń kó ti ṣe hà. Ìwọ ló máa ń kó sórí ìkíní. Okay. No, èmi náà ni mo ń ná. Kì í ṣe pé mo sọ pé. Mm-hmm.